We now discuss all the 5 numeric value type questions on relations which have appeared in the joint entrance examination main in the January 2024 session. These examinations were held from 27th January 2024 to 1st February 2024. So, we propose to answer all the 5 numeric value type questions on the topic relations. This is the first question that is asked, and this question has appeared in the joint entrance examination main held on 29th January 2024 in the second shift. This problem is based on the basic knowledge of a student at 11th and 12th class level. The given question is, let the set C is equal to the set of all ordered pairs x comma y such that x square minus 2 power y is equal to 2023, where x, y belongs to n, the set of natural numbers. Then sigma of x plus y, where the summation sigma runs over all those ordered pairs x comma y that belong to C, and that sigma of x plus y is equal to. So, we have the set C consisting of ordered pairs x comma y. X and y are natural numbers satisfying x square minus 2 power y is equal to 2023. Required to find sigma of x plus y, where the sigma runs over all those ordered pairs x comma y that belong to C. Let's now discuss the solution of the problem in detail. Given C is equal to the set of ordered pairs x comma y, where x, y belongs to natural numbers satisfying x square minus 2 power y is equal to 2023. That is equal to the set of ordered pairs x comma y, where x, y belongs to n, satisfying x square is equal to 2023 plus 2 power y. If we take y is equal to 1, then x square will be equal to 2023 plus 2 power y, that is 2 power 1, that is equal to 2023 plus 2, that is 2025, that is 45 square. So this will imply x is equal to 45 when y is equal to 1. Thus, the ordered pair x comma y satisfying the conditions that are given in C is equal to the ordered pair 45 comma 1 belongs to C. Now our question is it the only one ordered pair in C? Are there any? That we will now investigate. If x is a natural number and less than 45, x less than 45, then 2023 plus 2 power y is equal to x square, where x less than 45, x square will be less than 45 square. This will imply 2 power y is less than 2025 minus 2023, which is equal to 2. Thus we get 2 power y is less than 2, where y is a natural number. For what natural number y? We have 2 power y less than 2. For no natural number y, 2 power y is less than 2. So 2 power y is less than 2, and it is true. For no value of y belongs to n, this is true. So for x belongs to n, x less than 45, we do not find a solution for y. Now, if x belongs to n, x greater than 45, arguing as above, 2023 plus 2 power y is equal to x square, where x is greater than 45, x square is greater than 45 square. Then we get 2 power y is greater than 2025 minus 2023, that is equal to 2. And 2 power y is greater than 2, this is satisfied for no value of y belongs to n. Therefore, we do not find any solution for y. So thus, for any x other than 45, we do not find a solution for y. Therefore, C is equal to the set of those ordered pairs x comma y will be x is equal to 45, y is equal to 1. That means C is a singleton set consisting of the ordered pair 45, 1 only. Now required to find sigma x plus y, where the sigma runs on all those ordered pairs x comma y that belong to C, and we have only one. So x is 45, y is 1. So sigma x plus y will be 45 plus 1, that is equal to 46. So the answer to this question is 46, and that is the detailed discussion of the solution of the given problem, and it is an easy question. I am sure that you understood the solution of this problem. We now move on to question number 2, and this has appeared in the JEE Main exam held on 30th January 2024 in the second shift. The given question is the number of symmetric relations defined on the set consisting of 1, 2, 3, 4, which are not reflexive is. So required to find the number of symmetric relations defined on this set, 4-element set, which are not reflexive. And it is a formula based question. We now discuss the solution of the problem in detail. Let us recall, if let A is equal to the set consisting of 1, 2, 3, n, that means A is a set with n elements, then the number of relations defined on A, which are both reflexive and symmetric, is given by the formula 2 power n into n minus 1 by 2. These are the number of relations defined on A with n elements, which are both reflexive and symmetric, is given by 2 to the power of n into n minus 1 by 2. We also have another formula. The number of symmetric relations defined on A is equal to 2 to the power of n into n plus 1 by 2. These will be many when compared to the earlier one. This is reflexive and symmetric. This is 2 power n into n minus 1 by 2. These are only symmetric relations are 2 to the power of n into n plus 1 by 2. And if you want only just symmetric relations defined on A which are not reflexive, that is obtained by 2 to the power of n into n plus 1 by 2 minus 2 power n into n minus 1 by 2. That will give you just symmetric relations which are not reflexive. Agreed. So the number of relations defined on A which are symmetric but not reflexive is given by 2 to the power of n into n plus 1 by 2. This is a number of symmetric relations, minus 2 to the power of n into n minus 1 by 2. This is the number of relations which are both reflexive and symmetric. If you subtract, you will get symmetric but not reflexive. So let's move to our question. In our question, n is equal to 4. Given A is the set consisting of 1, 2, 3, 4. Therefore, the number of elements n is equal to 4. So what we want is the number of relations defined on A which are symmetric but not reflexive is in the above formula. Substitute n is equal to 4. So the above formula n is equal to 4. If you substitute n is equal to 4, 2 power n into n plus 1 by 2, that is 10, minus 2 power n into n minus 1 by 2 when n is 4, it is 6. 2 power 10 is 1024 minus 2 power 6 is 64. Where subtract now, you will get 960. So those are the number of relations defined on a set A with 4 elements which are symmetric but not reflexive is 960. The answer to this question is 960. That is the detailed discussion of the problem, and it is definitely an easy problem provided you remember these formulae. I am sure that you have understood the solution of this problem. We will now move on to the next problem, that's the third problem, and this problem has appeared in the JEE Main Examination held on 31st January 2024 in the first shift. The given question is, let A be a set consisting of the elements 1, 2, 3, 4 and R is a relation given by the ordered pair 1, 2, 2, 3, 1, 4 be a relation on A. Let S be the equivalence relation on A such that R is contained in S and the number of elements in this equivalence relation S on A is n. Then the minimum value of n is, now we have the given set A with 4 elements, that is 1, 2, 3, 4, and R is a relation consisting of 1, 2 ordered pair, 2, 3, 1, 4. This is a relation on A, and we have to find out S such that R is contained in S and S is an equivalence relation on A. And if the number of elements in S is n, then we have to find the minimum value of n is. Such a similar question has appeared in this session of the examinations only, but under a multiple choice question, which we have done that in the last video. The procedure what we adopt is same as that question. Let's now discuss the solution of the problem in detail. Given A is equal to the set consisting of the elements 1, 2, 3, 4, and we want to find n of S, number of elements present in S. What is S? Where S is the smallest equivalence relation on A, containing R, where R is the relation 1, 2, 2, 3, 1, 4. That means we have to extend this relation to an equivalence relation by adjoining the minimum number of ordered pairs to it, and thereby the extended set becomes, that will be S, will be an equivalence relation. So we recall, when a relation R on A is an equivalence relation, if it is reflexive, symmetric and transitive. Right. Now we have to extend this R by adjoining minimum number of ordered pairs such that the extended set S is the equivalence relation on A. Now we will discuss that how we do it in the next slide. And we have brought you a tabular form here. We have A, the given set consisting of 1, 2, 3, 4. We have R, the given relation on A, that is given as the ordered pair 1, 2, 2, 3, 1, 4. 3 ordered pairs are there. Now this is to be extended. After the extension, we will write under extended set. Now, the extension should be an equivalence relation, but we have to add the minimum number of ordered pairs, and to get an equivalence relation, the reflexivity must be achieved. To achieve reflexivity, and that reflexivity is not there in R, so we have to adjoin 1, 1, 2, 2, 3, 3, 4, 4 to R. So now we extend the old set 1, 2, 2, 3, 1, 4. Now the new ones after achieving the reflexivity. So the under extension we have now 7 ordered pairs. Now we see is a symmetry there in this set, in this extended set? No. 1, 2 is there, 2, 1 is not there. So also 2, 3, so also 1, 4. So we want to achieve the symmetry. To achieve the symmetry, we adjoin the reverse of 1, 2, 2, 1, 3, 2, 4, 1. So the reverse of these things. Now adjoin, now we got these ones, right? This is the extension. Now you see, is it reflexive? Yes. Is it symmetric? Yes, up to that. But is it transitive? No. So what do? We take 2, 1, compose with 1, 2, we will get 2, 2 which is already there. And if you take 2, 1, compose with 1, 4, you will get 2, 4, that is not there. That's not there. So to achieve transitivity, 2, 1, compose 1, 4 is 2, 4 which is not there. And we take 3, 2 and composition will not give you any new member by these elements. 3, 2 compose with 2, 1 will give you 3, 1, and 4, 1 when you compose with 1, 2 you will get 4, 2. And 2, 4 is there, 4, 2 is also there, symmetry is there, 3, 1 is there. To achieve symmetry, 1, 3 also you add. So now we adjoin these things, and after the extension we get this one. We get this one. Now again we ask the question, is the symmetry there? reflexivity? Yes. Is the symmetry there? Yes. Is the transitivity there? That we have to check. Now you see 4, 2 compose with 2, 3. We will give 4, 3 which is not there in this. So 4, 2 compose with 2, 3. We will get a new element 4, 3 and 3, 1 compose with 1, 1, 4 will give you 3, 4 and symmetry is also achieved. We will adjoin these. Right. So after the adjoinment we get this one. Now let's see how many ordered pairs these are. These are 3 plus 4, 7, 7 plus 3, 10 plus 4, 14 plus 2, 16. But you see, your set A is 1, 2, 3, 4. A cross A will have 4 into 4, that is 16 ordered pairs. Now this has 16 ordered pairs. That means this is A cross A. A cross A is also a relation. It's called a universal relation. And the universal relation is an equivalence relation. So you can check. It has all the 3 properties. And this is the A cross A and it is a universal relation, and a universal relation is always an equivalence relation. So now S is the equivalence relation. Thus we got, these are the 16 elements we have written down there. And and it is the smallest equivalence relation. We have been checking after each extension we are checking. Therefore, this will be smallest equivalence relation containing the given relation R. And therefore, n of S is equal to 16. The answer to this question is 16. The number of elements present in the equivalence relation S, that containing R, is 16. And that is the detailed discussion of the solution of the problem. And it is an easy question, but it is a time-taking question. Agreed. I am sure that you have understood the solution of this problem. We move on to the next problem. That's the 4th problem that appeared in the JEE Main exam held on 31st January 2024 in the second shift. The given question is, let A is equal to the set consisting of 1, 2, 3, etc. 100. Let R be a relation on A defined by x comma y belongs to R if and only if 2x is equal to 3y. Let R1 be a symmetric relation on A such that R is contained in R1 and the number of elements in R1 is n. Then the minimum value of n is, we are given a set A consisting of 1, 2, 3 up to 100. We are also given R is a relation on A defined by x comma y, the ordered pair belongs to R if and only if 2x is equal to 3y. And R1 is a symmetric relation on A such that R is contained in R1. That means R1 is the smallest symmetric relation containing R. And the number of elements in R1 is n. Then what is the minimum value of n? Required to find the minimum value of n. We now discuss the solution of the problem in detail. We have a given set consisting of the elements 1, 2, 3 up to 100. We are given R is a relation on A defined by x comma y belongs to R if and only if 2x is equal to 3y. 2x is equal to 3y is equivalent to x is to y is equal to 3 is to 2. Agreed. Agreed. Therefore, by this definition, R will be the set of all those ordered pairs x comma y, where x and y are the elements of A, satisfying 2x is equal to 3y. It is same as the now you see 3 comma 2 belongs to R. Why? 2x. 2 3s are 6, 3 2s are 6. 6 4, 6 comma 4. 2 6s are 12, 4 3s are 12. Like that, R consisting of all ordered pairs 3 comma 2 and multiples of 3 comma 2. 2 times 6 comma 4, 3 times 9 comma 6, etc. 33 times 99 comma 66. We have to stop here because A consists of just 100 natural numbers. And the number of ordered pairs in R, n of R is 33. Because 3, 6, 9, 99. That is 99 by 3 is 33. Agreed. Now what is that we want to do now? R1 is a symmetric relation such that R is contained in R1. That means R will be there. And to this set R, you have to adjoin certain number of ordered pairs such that after the adjoinment, the relation R1 is symmetric. What is the minimum number of ordered pairs that you have to adjoin there? So now, required to obtain a symmetric relation R1 on A such that R is contained in R1. We want a symmetric relation R1 containing R. So 3 comma 2 is there. To achieve symmetry, we must have 2 comma 3. That's not there in this, therefore you have to adjoin. 6 comma 4, 4 comma 6, 9 comma 6, 6 comma 9, 99 comma 66, that is 66 comma 99. To achieve the symmetry for the elements of R, we have to adjoin 2 comma 3, 4 comma 6, etc. 66 comma 99. How many elements? 2, 4, 6, 66. 66 by 2 is 33. That means 33 elements. That means for each element you have added. If A comma B belongs to R, you have added B comma A belongs to R1. So that's all. So these are also 33. Now to the old set R, adjoin these, we'll get R1. And R1 is a relation which is symmetric. So R1 is the R union the set consisting of 2 comma 3 comma 4 comma 6 etc. 66 comma 99. So now the minimum number of minimum value of n. What is n? N is the number of elements in R1. How many elements are there in R1? In the first 33, in the next one 33, 33 plus 33, 66. So it is a symmetric relation and R is contained in R1. The answer, the minimum number of elements in R1 is 33 plus 33, that is 66. That is the detailed discussion of the solution of the given problem. And it is certainly a very easy question. I am sure that you understood the solution of this problem. We now move on to the last question, that is the fifth question, that is given in JEE Main exam held on 1st February 2024 in the first session. The given question is, let A is equal to the set consisting of 1, 2, 3 up to 20. Let R1 and R2 be two relations on A such that R1 is equal to the set of ordered pairs A, B, where B is divisible by A, where A and B belongs to A, of course. And R2 is a set of all those ordered pairs A, B, where A, B belongs to A, satisfying A is an integral multiple of B. Then the number of elements in R1 minus R2 is equal to. We are given a set A consisting of the elements 1, 2, 3 up to 20, and we are also given two relations R1 and R2 defined on A. R1 is defined as the set of all those ordered pairs A, B, where B is divisible by A, and R2 is the set of all those ordered pairs A, B, where A is an integral multiple of B. We are asked to find the number of elements in R1 minus R2. We now discuss the solution of the problem in detail. We are given A, the set consisting of 1, 2, 3 up to 20. Given two relations R1 and R2 on A. R1 is defined as the set of all those ordered pairs A, B. B is divisible by A. When B is divisible by A, it is same as A divides B or A is a divisor of B. It is equal to the set of all those ordered pairs A, B, where A is a divisor of B. A, B, A is a divisor of B. No, A, B. So, 1 is a divisor of 1, 1 is a divisor of 2, 1 is a divisor of 3, 1 is a divisor of 20. That means 1, 1, 1, 2, 1, 3, 1, 20 will be there in R1. Not only that, 2 divides 2. 2 is a divisor of 2, 2 is a divisor of 4, 2 is a divisor of 8, 2 is a divisor of 20. So 2, 2, 4, etc. 2, 20 will be there. So now enumerated 1, 1 divides 1 is a divisor of 1, 1 is a divisor of 2, 1 is a divisor of 20. These are 20. 2 is a divisor of 2, 2 is a divisor of 4, 2 is a divisor of 20. These are 10 in number. 3 is divisor of 3, 3 is a divisor of 6, 3 is the divisor of 18. These are 6 in number. 4 is a divisor of 4, 4 is a divisor of 8, 4 is a divisor of 20. These are 5 in number. 5 is a divisor of 5, 5 is a divisor of 10, 5 is a divisor of 20. These are 20 by 5, 4 in number. 6 is a divisor of 6, 6 is a divisor of 12, 6 is a divisor of 18. These are 3 in number. 7 is a divisor of 7, 7 is a divisor of 14. These are 2 in number. 8 is a divisor of 8, 8 is a divisor of 16. These are 2 in number. 9 is a divisor of 9, 9 is a divisor of 18. These are 2 in number. 10 is a divisor of 10, 10 it is a divisor of 20. These are 2 in number. Now, from here onwards, 11 is a divisor of 11, one element only. 12 is a divisor of 12, one element only, etc., etc. 20 is a divisor of 20, one element only. So, how many elements are there in R1? N of R1 is equal to 20. 1 is a divisor, 20. 2 is a divisor, 10. 3 is a divisor, 6. 4 is a divisor, 5. 5 is a divisor, 4. 6 is a divisor, 3. 7 is a divisor, 2. 8 is a divisor, 2. 9 is a divisor, 2. 10 is a divisor, 2. From now onwards, 11 is a divisor of 11, 12 is a divisor of 12, 20 is a divisor of 20. That will be 1 plus 1 plus 1, 10 times. So now adding 20 plus 10 plus 6 plus 5 plus 4 plus 3 plus 4 into 2 plus 10 into 1, that is 66. Agreed. We have A, we have R1, and N of R1 is 66. We'll now go to see what is the relation R2. R2 is given as all those ordered pairs A comma B where A is an integral multiple of B. It is same as B divides A or B is a divisor of A. Right? Agreed. Agreed. Now, what is to be found? N of R1 minus R2. Now, let us see what is R1 minus R2. R1 minus R2 is equal to R1 minus R1 intersection R2. From the set theory, this is true. Right. R1 is a set, R2 is a set. R1 minus R2 will be R1 minus R1 intersection R2. And if you want, so how to find R1 intersection R2? So R1 intersection R2 is, write down the definition of R1. All ordered pairs A comma B where A is a divisor of B intersection. All those ordered pairs A comma B where B is a divisor of A. It is an intersection. Intersection means it is a set of all those ordered pairs A comma B. A is a divisor of B and B is a divisor of A. Now, A is a divisor of B, B is a divisor of A, where A and B belongs to capital A, consisting of 1, 2, 3, 20. Then what will happen? A divides B, B divides A, means A is equal to B in this case. In this case, because they are natural numbers. And that will be the set of all ordered pairs A comma B, where A comma B belongs to A and A is equal to B. That means it is a set of all those ordered pairs A comma A belongs to A. How many elements? So A is coming from A. So A has 20 elements. Therefore, R1 intersection R2 will have 20 elements. N of R1 intersection R2 will be 20. Now let's now talk about N of R1 minus R2 is equal to N of R1 minus N of R1 intersection R2. Yes. N of R1 is 66. N of R1 intersection R2 is 20. After subtraction, you will get 46. So, the number of elements in R1 minus R2 is given as 46. The answer to this question is 46, and that is the detailed discussion of the solution of all the 5 numerical value type questions from the section relations, and these questions have appeared in the JEE Main examination, which is conducted in the January 2024 session. That is about 5 days, and each day 2 question papers. And that is the end of the discussion of this video. I am sure that you understood the solutions of these 5 questions, and I wish you all the best. Thank you.